We've all felt that specific weight of knowing exactly what hard task needs to be done, while choosing a distraction instead. You have a project due, a workout planned, but you find yourself scrolling, snacking, delaying. This resistance is not weakness. It is an ancient evolutionary survival mechanism, designed strictly to conserve energy. For most of human history, burning calories on non-essential tasks was a threat to survival. So your brain evolved to prioritize the path of least resistance. When you try to fight this instinct with sheer willpower, you are competing against millions of years of biological programming. It is a battle against a system designed to keep you safe by keeping you comfortable. But hidden beneath that survival instinct is a second system. Your brain possesses dormant hardware designed to crave and reward the very difficulty you are avoiding. Research published in the March 2026 Nature journal suggests dopamine is more than a pleasure signal. It functions as an effort-amplified reward system that scales based on the friction you overcome. Complete a low-effort task, and dopamine release is small. Complete a high-effort task, and your brain releases a significantly larger surge. This compounding multiplier activates when acetylcholine releases during work. Friction triggers the nucleus accumbens dopamine flood upon completion. Because this system is an energy-intensive process, your brain keeps it offline by default. It requires intentional, deliberate action to engage the circuitry. When this system is engaged repeatedly, the brain begins to predict that hard things lead to superior outcomes. It starts to prioritize the high-effort path because it anticipates the larger biological payoff. This suggests your brain is wired to provide a more intense reward for suffering than comfort, provided you can bridge the initial gap of resistance. If this high-effort reward system is available to us, we have to ask why our default state is still to avoid the work. This is the result of a conflict between the prefrontal cortex, which handles your logical long-term goals, and the basal ganglia, the autopilot system that pushes for familiar, low-energy behaviors. The logic center is metabolically expensive. The prefrontal cortex consumes a massive amount of energy, while the autopilot basal ganglia runs at near zero cost. When your energy-conserving autopilot looks at a difficult to-do list, it doesn't see a chance for self-improvement. It sees a drain on your energy reserves and flags the task as a threat. Because the brain processes these tasks emotionally rather than logically. Bypassing the resistance requires more than just wanting it more. It requires a specific neural override. That override happens in the anterior mid-cingulate cortex, or AMCC. This region acts as a hub for managing tenacity, weighing effort against potential gains. Neuroimaging shows that the AMCC physically increases in size and density when you successfully execute tasks you did not want to do. The AMCC behaves like a muscle, adding neurological mass only when forced to work against active resistance. This growth is context-dependent. If you perform a difficult task that you find inherently enjoyable, the AMCC doesn't show the same structural change. The growth requires the presence of reluctance. While dopamine serves as the brain's motivation currency, deliberate effort is the only investment that yields compound interest in the form of increased neural density. These physical changes in the AMCC provide a neurological foundation for persistence. By choosing the difficult path, you are quite literally building the internal machinery required to make the next hard task easier. To move from avoiding effort to craving it, you have to follow a specific protocol to upgrade your brain's hardware. First, complete one micro suck every day, a small unwanted task, like a cold shower, or extra minutes of deep work, designated specifically to trigger the AMCC's growth response. Second, stack a genuine reward immediately after the effort. This reinforces the circuit, teaching the brain that the friction of the work is the direct precursor to a dopamine spike. Third, use micro goals to bypass the autopilot. By telling yourself to just put on your gym shoes rather than finish a workout, you avoid triggering the basal ganglia's energy threat response. Fourth, maintain the physiological baseline. 3 hours of moderate cardiovascular exercise per week is the minimum requirement to support the blood flow and plasticity needed for this neural development. Finally, celebrate the effort rather than the result. When you learn to value the friction itself, the dopamine trigger shifts away from the finish line and onto the act of working. We often assume that highly productive people were born with a different kind of motivation than the rest of us, but the science suggests they simply accumulated enough repetitions to enlarge their AMCC. They did enough hard things they didn't want to do until their brains rewired to expect a reward for difficulty. You have the same biological potential. Your brain is a plastic organ that adapts to the demands you place on it, and your capacity to crave difficulty begins the moment you choose action over comfort.